Dear students, in this video we are going to discuss the Newton's second law of the motion. Before this, even in our previous video we discussed the Newton's first law of the motion. In Newton's first law, you discussed in the Newton's first law that Newton's first law answers the questions like that what happens to an object, what happens to an object when no force act on it. Act on it. And so answer to this question was given by Newton's first law. So we discussed that what happens to an object that when no net force is or no force is acting on an object. So the answer to this questions was that the object is at rest. If it is at rest, object is at rest, it will remain at rest, and if it is in motion, then it will continue its motion with constant velocity. Okay, with constant velocity. So we define the question answer to this question, that what happens to an object when no force is acting on it, and question to this answer was given by Newton's first law. He answered that if the body is at rest, it will remain at rest, and if it is in motion or it is moving, then it will continue its state of motion with the constant velocity. Now we comes to the Newton's second law. Okay, now we comes to Newton's second law of motion, and Newton's second law tells us that what happens to an object, what happens to an object under the action of non-zero resultant force, under non-zero resultant force. Okay, so this is the question, this the main question of the Newton second law. Newton first law was about that what happens to an object when no force act on it. Then opposite situation is in the Newton second law is that what happens to an object under the action of non-zero resultant force. Non-zero resultant force means here that when multiple forces are acting on an object, then their resultant is non-zero. Then what will happen to the object when there is non-zero resultant force? So Newton's second law will test by Newton's second law we can find the answer to this question. For this, let us perform the simple experiment, and let's suppose we have an ice block, that is this one is, let's suppose this is the block of ice. Okay, and this is ice block and is laying on the frictionless surface on which the force of friction is absent. Frictionless surface. Okay, now it is a frictionless surface. Now if we apply some force on it, if we apply some force in the horizontal direction, so this force is, we are applying the force in the horizontal direction, then what will happen to this ice block? So it will produce an acceleration in the ice block. Ice block will move under the action of this force, and so it will accelerate. This force will produce acceleration. So this will produce, which can be represented by A. This horizontal force which will move the block on the frictionless horizontal surface, and acceleration A is produced in the block. Now let's suppose now if we double the force. Okay, now we are applying a double force, that is, now we increase the magnitude of the force on block. Let's suppose block is the same, but now the magnitude of the force we have applied the double force as compared to the first one. Okay, so we are applying the 2F force in the horizontal direction. Again, force is in the horizontal direction. Okay, now what will happen to this block? Again, this block, it will accelerate the block. Now it will produce the acceleration 2A, that is, acceleration is double. Okay, acceleration is also double. Now we apply the force when we increase the force of magnitude of the force in this case, and now we are applying the force of 2F magnitude, then it will produce the double acceleration as compared to the first case. Now the acceleration is also doubled. Okay, now repeat the experiment, and now let's suppose again we have the same block. Suppose the block is again same. Now we further increase the magnitude of the force. Now we apply the force, triple force, as compared to the first one. Now the magnitude of the force is 3F. Again, the block is laying on the frictionless horizontal surface. Again, this force will accelerate the block. So this force will accelerate the block, and now the acceleration is 3A. So it will produce, the acceleration is now tripled. Now when the force is tripled, then the acceleration is also tripled. So acceleration is 3A. Okay, so we can conclude from this experiments, by repetition of this experiments, that we can say that acceleration, here the acceleration which is produced in the block as a result of by applying the non-zero force, so the acceleration is, we can say, is directly proportional to the resultant force F. It's directly proportional to the resultant force F, or in other words we can say that acceleration is directly proportional to force F. Okay, so this one is the of one result. This is the one result of our experiment. Now again we can repeat the this experiment, and let's suppose the acceleration of an object also depends on the mass. So the second point here about the Newton's second law is that acceleration of an object is depend on its mass. Depend on its mass. Okay, now again we can perform the experiment, and let's suppose now again we have a block of ice, and again we have, this one is the ice block. Okay, and this one is the ice block, and now if we apply the force F on it, okay, then it will accelerate with an acceleration A. So here in this case the acceleration is a. Okay, now we can repeat the experiment. As we have already said that acceleration of an object depends on its mass. Now here if we increase the mass, okay, now if we use the block of ice of same mass, here we use the two blocks instead of one block. Now we use the two ice blocks, and again we are, but the force is the same. Now we are applying the force of same magnitude as in the first case. Now the magnitude of the force is same. Now we apply the horizontal force. It will accelerate the blocks. Now the acceleration will be a by 2. Now the acceleration is half. It will be equal to, it will produce an acceleration of a by 2. Okay, now again if we repeat the same experiment, and now let's suppose, now if we triple the mass, now we use the three blocks of the same masses, and here now we have the three blocks instead of one or two blocks. Here now we are having the three blocks, three ice blocks, and again we are applying an horizontal force of same magnitude as we have used in the first and second case. So this is the first case, this one is the second one, and this is the third one. Now we repeat the experiment with the tripled mass. When the mass of the block is tripled, now we have used the three ice block. Again this force will produce an acceleration. Now in this case the acceleration will be a by 3. So now it is the 1/3 acceleration. It will produce the 1/3 of acceleration of first case. Okay, as here you have seen that as we are increasing the mass, as a result it reduced the acceleration. So from here we can conclude this experiment, and we can get our second result, that is acceleration of an object is inversely proportional to the mass of an object. When you increase the mass, then it will reduce the acceleration. Okay, so now we can make a statement about the acceleration. Now we can make statement by combining the two results, and this statement is that acceleration of an object is directly proportional to the net force which is applying on it, directly proportional to the net force and acting on it, and it is inversely proportional to mass of an object. So we can conclude this two results from our experiment in the form of statements that acceleration of an object is directly proportional to the force of an object and inversely proportional to mass of an object. So we can, in a mathematical form, we can write it like A is proportional to F over M. So here we can say that F is directly proportional to the force, and it is inversely proportional to the mass of an object. That is, A is directly proportional to F and A is inversely proportional to mass of an object. So now we can write the Newton's second law in mathematical form. Newton's second law of motion in mathematical form. So we are ready to write it in the mathematical form. So what will be the mathematical form of the Newton's second law? In mathematical form, we can say that the resultant force, here the summation of F represents the resultant force. So summation is here for resultant force. Summation F will be equal to MA, or F is equal to MA. So this equation has the vector expression, so we can write it in 3 dimensions. So we can write it like resultant force acting in the x direction, so it will be equal to max, and resultant force which is acting in the y direction, it will be equal to fmay, and similarly this equation in the z direction will be equal to maz. So now we come to the unit of force. Okay, now what are the unit of force? How we can measure the force which we are applying on an object? So there are the different ways to define the unit of force. The first, we have the SI system of units. This is the one system of units in which we usually measure the quantity, physical quantity. So in a SI system of the units, the unit of force, we can define the force as when acting on an object, when force is acting on an object of mass of 1 kilogram mass. So the force on which the object on which we are applying the force, the mass of that object is 1 kilogram, and as we have already discussed, that when force acts on an object, it produces acceleration in that object. So it will produce an acceleration of 1 meter per second square. So we can define the SI unit of force are 1 Newton, and 1 Newton is equal to the 1 kilogram meter per second square. Okay, kilogram meter per second square. So this is the in SI system of the unit of force are Newton, which are equal to 1 kilogram meter per second. That is force which is acting on 1 Newton force when act on an object of mass 1 kg, and it will produce an acceleration of 1 meter per second square. Now there is another system of the units which is called as British engineering system of units. So we have another system of units, British engineering system of units. In British engineering system of units, the unit of force can be defined as a pound. Okay, in that system, unit of force are the pound, unit of force. And so we can represent the pound by symbol LB, and so it can be defined as, how we can define the unit of force? Pounds in the British engineering system, that is when a force of 1 pound when acting on an object, whose mass is object of 1 slug. Okay, now the system in the British engineering system, the unit of mass are the slug. 1 slug mass when the force is acting on an object of 1 slug mass and it produce acceleration. Okay, it will produce an acceleration of 1 feet per second square. Okay, so we can write that 1 pound is equal to 1 slug feet per second square. So 1 pound is equal to 1 pound force is equal to 1 slug feet per second square. That is, when force of 1 pound acting on any object of mass 1 slug, it will produce an acceleration of 1 feet per second square. So now we can summarize this units of force, acceleration, and mass in the form of table. Let's suppose we can make the table. Here we make the column of the system of units. Okay, and then our next column will be about mass, and then next it is acceleration, and then our next column will be about the force. Okay, then we can write in SI system. We have the two system of units, SI system of the units, and then we have the British engineering system of units. Okay, and then in SI system of the units, the unit of mass are kilogram, and then in the British engineering system, the unit of mass are slug. And in acceleration in SI system can be measured in the unit of meter per second square, and in British engineering system it can be measured in the unit of feet per second square. So the unit of force are Newton, and 1 Newton in the SI system is equal to kilogram meter per second square, and in British engineering system the unit of force are pounds, and 1 pound is equal to slug feet per second square. So one convenient approximation which can be made that 1 Newton is equal to 1 by 4 pound. So this is the conversion of the unit from Newton to pound. Thanks for watching. For more videos, please subscribe our channel.